discuss in more length and trying to stick to the schedule. Let's move on to the second lightning talk of today, which will be shown by Duncan Sparrow. And it seems that showing the slides is working for Duncan, right?
I think so. What are you seeing?
We see your PowerPoint open, but not in presentation mode yet.
Okay. Let me get this out of the way.
So Duncan is going to bring some fun into our meeting here because he will be presenting something about QuadBlockQuiz, which involves Elixir and quizzes. So I'm very excited to see how things will be going. Okay.
Does that look about the right size? Is that?
Yeah, I think that's good.
Wonderful. Well, hello, I'm Duncan, and I'm going to be talking about a game that hopefully you'll have some fun while learning some supply chain cybersecurity and why Beam OTP is so good for cybersecurity. The game is QuadBlockQuiz. Save the Tetrominoes world from supply chain vulnerabilities. QuadBlockQuiz is live right now at quadblockquiz.org:4000. The game is a mashup of quad blocks and a trivia quiz with some cyber attacks, licensing lawsuits, and cybersecurity thrown in. The game was introduced at the RSA conference, Supply Chain Village. RSA conference is the largest cybersecurity conference in the world. They needed a supply chain game, so I mashed up my passion for cybersecurity with my love of Elixir OTP, and I created QuadBlockQuiz. The game was a hit at RSAC, and it was also a hit when it was reprised at B-Sides Las Vegas, a big hacker conference. It will also be used as part of an open course in cybersecurity. QuadBlockQuiz starts off as a typical falling bricks game, where the arrows guide the falling of the brick. You get points for each brick. You get points for completing rows. Looks like I might be going to be completing a row here. Wait, what happened? A block changed color. Just like in the real world, vulnerabilities appear. Vulnerabilities are indicated by the yellow-gray block. A row is not complete unless it's free from vulnerabilities and some other troublesome blocks, including licensing issues, cyber attacks, and lawsuits. Now, you don't need to know the answers before you play. The purpose is to teach you supply chain security. Just read the page and you should be able to answer the question. Besides points, you get power-ups. For example, getting the SBOM question correct wins you the delete power-up, which lets you delete or blow up those pesky vulnerabilities. Correct automation answers win you the move power-up, which lets you move blocks into those holes. And the Phoenix power-up gets you rebirth, which clears the whole board and is really useful if you're attacked. I won't cover all the cybersecurity taught in the game, but one aspect I will cover is software bill of materials, or SBOM. Now, what is an SBOM? It's a listing of all your software components and their components, etc. There's a really lot of good information about SBOMs at nta.gov/SBOM, but I'll confess I'm biased. I was part of the group that created a lot of that content. Now, SBOM's been receiving a lot more attention since May 12th, when President Biden explicitly called for SBOMs in his executive order on securing supply chains. If you develop software, you should know what is in that software. If you purchase or use software, you should require your suppliers to know what's in that software. So to learn more, go to nti.gov/SBOM. And this game even has an SBOM, which was created using hex/SBOM. So you guys should put this in all your code. And for Elixir, the equivalent is rebar/SBOM, which does exist. Now, cybersecurity consists of confidentiality, i.e. private communications and data, integrity, i.e. nobody changes your data either at rest or in transit, and availability, i.e. the systems and your data are there when you want them to be. So pretty simple to say, pretty hard to do, as recent events have shown. Now, new work is showing that one way to achieve the CIA triad is with the DIE triad for distributed, immutable, and ephemeral. properties that the Erlang ecosystem naturally supports. Now, OTP was, when Ericsson developed Erlang back in the 80s, they put in the OTP libraries to provide a lot of DIE. So now OTP stands for One Tough Platform. Apologies, I keep screwing up my cursor. So let's talk about making the game. There's an easy-to-use Elixir web server known as Phoenix. It scales really well, making use of the Elixir lightweight processes. So it actually gives each user their own web server for each transaction. As a security geek, I really like that because it drastically reduces the attack surface. And because this game is a volunteer effort, I also like that Phoenix is known for its simplicity and for, quote, decreasing the cognitive load on developers, end quote, i.e. it's simple enough that even I can program in it and write maintainable software. Of course, I went one step further, and I started with an open source QuadBlocks project by Grox.io. Grox is Bruce Tate's company. Bruce teaches software development and uses the QuadBlocks repo to teach several different courses, Elixir, Phoenix, LiveView. I just forked the repo and added the quiz and cybersecurity aspects, so it can be used in cybersecurity courses, such as will be used by One Planet Education Network. So the one thing I want you to take away from this talk is that cybersecurity desires confidentiality, integrity, and availability. And to get cybersecurity, use the beam and OTP to get distributed, immutable, and ephemeral. I never say that word right. Now, don't misunderstand. You can still program bad security in Erlang or Elixir, but they are naturally support better security than most other popular languages. So what should you do now? You should go play the game. There's never enough time. Thank you for yours.
Thank you very much for your presentation, Duncan. This was very inspiring, and I'm looking forward to playing the game. Are there any questions, or is everybody now busy logging on and trying to get first results and placing themselves on the board? Nothing yet. I think it's interesting that you have the same impression as at least Vicky, who is later presenting in our workshop, also about security and how to identify interesting security-related parts of your code. And if I recall correctly from also previously talking to her, the way that OTP and Elixir structure the code makes it indeed much more viable to identify these places quickly and with some hope not to overlook things, right?
Correct. So there's sort of two levels to that. One is you naturally make fewer mistakes because the whole let it fail philosophy allows, all said and done, most hacker techniques are taking advantage of mistakes in people's code. Well, Erlang is designed basically to let you make mistakes and still work. So the hackers can't take advantage of it. And then the second layer is, as you just mentioned, all said and done, functional programming in general, but in particular, Erlang and Elixir, it's actually easier to see those mistakes that are the more, I'll call it design mistakes that hackers again take advantage of. So again, you can still make design mistakes in Elixir and Elixir and Erlang, but it's easier to find. It's less likely to make them, and it's easier to find them. So those are. I actually don't think our ecosystem does enough to. All said and done, cybersecurity is a really big deal right now, and nobody other than us realizes how good our stuff is, and we really should do a better job at basically teaching everybody else how to do this. And that's what I'm out there trying to do. And that's how I made the game. And I'm very involved in the software bill of materials effort. This new executive order that just came out is going to be, I think, really groundbreaking in changing the software industry. And we're really uniquely positioned to take advantage of that. People are going to start looking to, hey, don't buy $1 trillion worth of security gear to put on the end. Just write better programs to begin with. Oh, how do you do that? Oh, use Erlang and Elixir.
Yeah. It's really a pity that security is always added as an afterthought, right? And we know we should not do it, but people tend to, rely on other tools in order to prevent certain mistakes that could have been spotted earlier, or just addressed directly by the semantics of a library, for example.
Yeah.
Right. So one thing I got, maybe as a kind of last question from my side, I got slightly confused by when I looked at the title. So supply chain management, but for software, right?
Well, correct. So one of the big issues, so in the early days, hackers sort of directly attacked the program. People started getting better at being a little bit better, at least lately, in security. So what now hackers have discovered is I don't have to attack the program. I just have to attack the underlying libraries, because most software developers don't even know what software they're using. So I'm very involved in this effort the US government is doing in what's called supply chain transparency, which really means having a software bill of materials, which really means just knowing what software you uses and what software it uses and what software it uses. And most programs are actually very deep. They're 10 to 100 layers deep in their dependencies. And most of the attacks occur deep in those dependencies. So there's a lot of effort in sort of basically trying to secure up the supply chain of software. Most of the big hacks of 2021 were supply chain hacks. And that's what sort of prompted the issue.
Nice. Very
and again, so we're sort of buried, our ecosystem sort of buried in that infrastructure, and people don't realize it has way less problems than most of these other infrastructures. So again, I think we got to get the word out there.
Mm-hmm. Okay, I think there is one more question by Peter from Roy. So let's see if it works putting him on stage. Hi, Peter.
Hello. You can't see me, but my camera is supposedly working, right?
Yes.
So my question is, you said deep, but you said that there's lots of dependencies that go deep from piece of software, but also broad, right? So the number of these can be hundreds or thousands, right?
Or thousands, even as high as 10,000, correct. It is doable. There are companies doing it today. The financial industry has basically done it for years because obviously they don't want to lose money getting hacked. Right. They've been pretty private about it, so they haven't been sharing maybe as much as I would have liked. The medical industry has just started doing it and has some really major, really good efforts going there because again, now people are literally dying because of computer hacks. And so obviously you want to prevent deaths, so people are doing it more there. The really good thing about it is, 80% of all software is open, some say higher, is open source. And for all open source software, you only have to do it once.
But so, then you need to digitally sign it so nobody knows you've actually modified the binary or something, right? I mean,
well, okay, there's levels of attack. Yes, that is, just because you haven't signed it doesn't mean it's useful. It would be more useful if it was digitally signed, because then the next layer of attack is, like there was actually some big attacks this year that actually affected the development side of the supply chain. So yes, it would be better to do that also. But even one layer of SBOM, even one layer of software bill of materials, even without signing it, is better than nothing. Because it turns out there's been some studies done, and most people, once they actually see their list of things, realize they're using stuff they don't really need to use, or they have 4 copies of one thing, or they have 2 different versions of the same thing in their code. So sort of each layer of depth that you add adds value. Most of the big open source project, the Linux Foundation, is very big in this effort. So there's going to start signing all the Linux Foundation code, which if you think about it, it's a pretty large chunk of the infrastructure. So if systems like Erlang and Elixir now have SBOM and now have the ability for developers to make SBOMs as part of their build process, you just include the dependency / SBOM and use it. Once you give that capability, the developers will decide their threat level. And again, yes, against the higher level threats, you need even fancier code signing and worry about man-in-the-middle attacks on your development systems. But those are pretty fancy. 99.9% of attacks aren't that fancy. I'm a hacker. I like to attack things. I don't need to get that fancy because people don't do the simple stuff. Let's do the simple stuff first, then we'll worry about the more complicated stuff.
Great.
Cool. I see some lively discussion continuing at the table in the launch. So thank you for all the speakers again that today so far gave the presentations on all the questions that we received and were answered. We will meet here back again in 25 minutes for the keynote on Dialyzer. So if you ever wrote Erlang or Elixir code, you probably used that tool, and I'm really looking forward to the insights that Kostas has. And so let's meet in the launch now at the tables, and back here in